Now in this session we are going to see the angle of acceptance and numerical aperture in an optical fibers. Now how does a ray propagates in a fiber? If a light is transmitted into a core of an optical fiber from the surrounding medium of refractive index n0 at an angle theta naught at a point A which is less than the refractive index n1 of core, it bends towards the normal. This bending increases the angle of incidence at the core and the cladding interface. For smaller angle of incidence theta I at A, the angle of incidence at core and cladding interface is more than the critical angle, that is 90 minus theta 1. At B, total internal reflections takes place as shown in the figure. Now we will see in the figure how exactly what I explained here can be explained in this figure. Now at a point A, at point A is nothing but when a ray is entering from a refractive index of medium n0. n0 means here in this case we take it as air. Air is having refractive index of n0 which is nothing but 1, and n1 is the refractive index of the core and n2 is the refractive index of the cladding. We start with this here as refractive index of core is more than the refractive index of the cladding. That means the core is a denser medium and cladding is a rarer medium, and n0 it is nothing but a refractive index of air which is very much less when compared to n2. Now see here, when a ray of light is entering from a rarer medium, refractive index n0 at an angle theta naught at a point A which is less than the refractive index of n1 of core, it bends towards the normal. That means a ray is passing from a rarer medium to a denser medium. The ray bends towards the normal. So what is happening here? If theta I is small, theta 1 will be small. When theta 1 is small, 90 minus theta 1 will be more. See, this bending increases the angle of incidence at core and cladding interface. B is a point of core and cladding interface. Interface is the separation between the two medium. For smaller angle of incidence theta I at A, the angle of incidence at core and cladding interface is more than the critical angle 90 minus theta 1 at a point B. Therefore, total internal deflection is taking place. Now here, the major important point here is at a point B, if the angle of incidence, that is 90 minus theta, is greater than the critical angle, then only at a point B the ray is totally internally reflected back. This angle of incidence at a point B, 90 minus theta 1, depends upon the angle of incidence which is entering from the air into the core, which is nothing but a theta I angle of incidence. When this theta I is small, 90 minus theta 1 at a point B becomes more than the critical angle, then only total internal reflection will take place. Now we will see the next case. If theta I, that is angle of incidence at a point A, is increased, the angle of incidence at the core and cladding interface is equal to the critical angle. You can see in the figure there, at a point B, 90 minus theta 1 becomes equal to the critical angle. Then what is critical angle? The angle of incidence becomes critical angle when the angle of refraction becomes 90 degrees. That means at a point B, angle of refraction is 90 degrees. Therefore, the 90 minus theta 1 is called as a critical angle. So how this it is coming to critical angle? When theta I at point A is increased, 90 minus theta 1 at point B is decreased and is becoming equal to the critical angle. Therefore, what is happening? The path of the light is grazing the two medium, core and the cladding. Next, if you see another case, if theta I is still more increased than theta naught, the angle of incidence at B is less than the critical angle. The path is shown below. Now, if you look at the third figure here, if the angle of incidence theta I is greater than theta naught, that means some particular angle which is more. Now, what is happening? The angle of incidence at point B is becoming lesser and lesser. When the angle of incidence is not greater than critical angle, what will happen? The ray passes from a denser one medium to another medium. You can see the figure there. Arrow is going into the N2. That means light is transmitting into the cladding. So what will happen? Light is nothing but it is carrying data, information. That means instead of undergoing total internal reflection, it is leaking into the cladding. That means transmission is lost. Information is being lost. So what is the condition for total internal reflection to take place is the first condition where theta I should be less than theta naught. For smaller angles of incidence, then at a point B, angle of incidence at point B becomes greater than the critical angle, then total internal reflection will take place. This is the propagation condition of a light in a fiber. Now we will see the further expressions. Expression for acceptance angle or the numerical aperture. Now let us consider a special case where ray of light suffers critical incidence at a point B. N0, N1 and N0 be the refractive indices of the surrounding medium, core and cladding. N1 is greater than N2 greater than N0. That means here we are taking the optical fiber in which the core, it has been clearly mentioned, inside part is core, outside is cladding. Core is having refractive index of N1, cladding is having refractive index of N2 and the surrounding medium is N0. And the order of refractive indices is given by the condition N1 greater than N2 greater than N0. That means N0 is the value of N0, refractive index of N0 surrounding medium is less compared to cladding, and still cladding is less compared to core. Refractive index of cladding is less compared to refractive index of the core. So core becomes a more denser medium than the cladding. Now what is happening? Now our major concern is at a point A and at a point B. And we have taken the angle of incidence at a point B. We have taken a special case as critical incidence. That means 90 minus theta 1 becomes equal to critical angle, that is theta C. So the ray is transmitting, the ray, it is nothing, grazing the two interfaces. That means N1 and N2, it is just angle of refraction is B is 90 degrees. Now we will consider this case to derive expression for the angle of acceptance or the numerical aperture. Now ray OA at a point, at entry point into the core A, by applying the Snell's law, N0 sin theta naught is equal to N1 sin theta 1. That means at a point A, angle of incidence is theta naught, angle of refraction at a point A is theta 1. So N0 is the refractive index in the surrounding medium is N0 and refractive index of core is N1. So from Snell's law, N0 sin theta naught is equal to N1 sin theta 1. This becomes equation 1. Next, at a point B, the angle of incidence is equal to 90 minus theta 1. Applying the Snell's law at point B, N1 sin of 90 minus theta 1 is equal to N2 sin 90. Since it is a critical angle, we have taken here in this figure, it is the critical angle of incidence we have taken at a point B. 90 minus theta 1 becomes angle of incidence at a point B and angle of refraction becomes 90 degrees. So applying here N1 sin of 90 minus theta 1 is equal to N2 sin 90. So it sin 90 minus theta 1 is nothing but cos theta 1. So N1 cos theta 1 is equal to N2 sin 90 is 1. Therefore, rearranging the terms, you are getting as cos theta 1 is equal to N2 by N1. This is equation 2. Rewriting equation 1, we have sin theta naught is equal to N1 by N0 into sin theta 1. Substituting the value of theta naught, we are getting N1 by N0. Sin theta 1 is nothing but it can be written as 1 minus cos square theta 1. So, substituting the value of cos theta 1 value into the equation 2. What is here? We are getting sin theta naught is equal to N1 by N0 into root of 1 minus N2 square by N1 square is equal to root of N1 square minus N2 square by N0 square. It is just writing the value of cos theta value from equation 2 into the above equation. You are getting, rearranging the terms, N1 square, you are getting, if the medium here, you are getting sin theta naught is equal to root of N1 square minus N2 square by N0. Now, if the medium surrounding the fiber is in air, that means N0 is equal to 1. So, what will happen? Sin theta naught is equal to root of N1 square minus N2 square, where sin theta naught is equal to, which is nothing but a numerical aperture. Sin theta naught is called as a numerical aperture and theta naught is called as angle of acceptance. So, rearrange what sin theta naught I am writing as NA. So, it is nothing but N1 square minus N2 square. N1 is the refractive index of the core and N2 is the refractive index of the cladding. Now we define the angle of acceptance. Theta naught is the maximum angle of incidence on core for which total internal reflection takes place inside the core. So in order to have a total internal reflection, the angle of acceptance is the maximum angle of incidence on core for which total internal reflection takes place inside the core. This is called as angle of acceptance. Next is condition of propagation. Light is transmitted into the fiber only when theta I is less than theta naught. Taking sign on both the conditions, both sides, sin theta I is less than sin theta naught. We know that sin theta naught is nothing but a root of n1 square minus n2 square, which is nothing but a numerical aperture. So sin theta I should be less than NA. It is a numerical aperture. Only when theta I is angle of incidence is less than theta naught, then only total internal reflection will take place. Therefore, this is the only condition for the propagation of light through an optical fiber. Next, we see the fractional index change delta. It is a ratio of refractive index difference between the core and the cladding to the refractive index of the core of an optical fiber. Refractive index is delta. It is fractional index change is denoted by delta. That is nothing but the difference in the refractive indices. That is ratio of n1 minus n2 by n1. It is called as a refractive index change. Rearranging this term, we are getting n1 minus n2 can be written as n1 delta. Delta is nothing but a fractional index change. Now we see the relation between NA and delta. We know that NA is equal to root of n1 square minus n2 square. It is nothing but a square minus b square formula. So we are rearranging it as a plus b into a minus b. n1 plus n2 is taken as n1 into delta because n1 is approximated to n2. So we can take that as n1 minus n2, we are taking it as n1 delta. Substitute the value of n1 delta here. So you are getting, since n1 is approximated to n2, we are writing as n1 plus n2 as 2n1. n1 plus n2 is taken as 2n1 square into delta. So Na can be written as root of 2n1 square delta. Rearranging the terms, Na can be written as n1 into root of 2 delta. This is the relation between Na and delta. Thank you.